Today on This Week Health.
I'm interested in how machine learning tools are implemented and designed and brought to the bedside. And I realized that actually there aren't very many cases where surgeons use these types of tools at the bedside or in the operating room. How can we design and implement these types of tools in new ways so that they are more useful?
Welcome to This Week Health community. This is Town Hall, a show hosted by leaders on the front lines with interviews of people making things happen in healthcare with technology. My name is Bill Russell, the creator of This Week Health, a set of channels designed to amplify great thinking to propel healthcare forward. We want to thank our show sponsors, Olive, Rubrik, Trellix, Hillrom, Medigate, and F5 in partnership with Sirius Healthcare for investing in our mission to develop the next generation of health leaders. Now, on to our show.
Hello, I'm Jake Lancaster, an internal medicine physician and the Chief Medical Information Officer for Baptist Memorial Healthcare out of Memphis, Tennessee. And today I'm going to be talking with Jayson Marwaha, a general surgeon and a NLM fellow at Beth Israel. Jayson, welcome to the program.
Thanks so much, Jake. I'm excited to be here.
Can you tell the audience just a little bit about yourself and what you do with the NLM Fellowship?
Yeah, sure. So again, thanks for having me. I'm Jayson. I am NLM fellow, as Jake said, at Beth Israel Deaconess in a joint informatics fellowship between BI and Harvard Medical School. And I'm also a general surgery resident. And so I'm interested in doing research and learning more about informatics, is how it intersects with surgery and how it can be made more useful to surgeons and surgical patients. And more broadly, I'm interested sort of in how machine learning tools are implemented and designed and brought to the bedside. And I think one of the big reasons why I became more interested in sort of the implementation science around machine learning tools is because as I started learning more about the use of ML in surgery, I realized that actually there aren't very many cases where surgeons use these types of tools at the bedside or in the operating room. And so I figured one, I think, meaningful thing to start studying and learning more about is how can we design and implement these types of tools in new ways so that they are, again, more useful to the people that end up using them.
Well, thank you. And thank you so much for making the time to come on. Certainly a fascinating background. Anytime I meet a surgeon who's also doing informatics, I'm very impressed with the ability to balance those two commitments. Especially the surgery residency part. I know that can be very time consuming. But I've been fascinated by some of the articles that you've written related to implementation of machine learning and artificial intelligence. We talk a lot about artificial intelligence in medicine, but we don't often talk about some of the challenges with the implementation of artificial intelligence. And so can we just start there? And so let's just start with the basic premise of all the AI software that is out there, how much is actually being used in clinical practice today?
That's an excellent question. And I think that when I started first learning more and more about the field, I realized that I think that everyone sort of there is a common, it's tempting to sort of want to equate a good AUC or like a good predictive performance of your model with the real world utility, when in fact those two things are not the same. Building a useful model, development and validation of a model in silico is only a very, very tiny portion of actually making it useful in clinical practice. And as a result of this overlooking the steps that you have to go through in order to bring these types of models to the bedside, because a lot of subsequent steps have been overlooked, there's actually very little machine learning based tools that are actually used at the bedside, in particular in surgery. And I know more broadly in medicine that this is the case as well. In large health systems, when are clinicians using machine learning-based prediction tools as a part of their everyday clinical practice? I would argue very, very rarely. And as I started to learn more and more about this issue, I've realized that there are many, many steps that you need to go to in order to make something useful. And I think that it's a code that I'm not sure has been totally cracked yet. On a related note, actually, there is a great review and systematic review that came out in Nature Digital Medicine about a month or a month and a half ago that speaks to this very point. It's not about surgery specifically, but they essentially they performed a systematic review of all studies that evaluated the use of AI clinical prediction tools at the bedside and found that there was little to no significant benefit in terms of patient outcomes. I think that the median AUC of every actual model included in their study was amazing. It was like 8.8 something or the other. Like, all these models do their job well, but delivering a prediction at the point of care is only one teeny tiny portion of what you need to do in order to make a prediction model useful.
That's a very important point. MIT has this program. It's like a 6-week program for health executives to understand artificial intelligence in medicine and how it can be used. So I did that last summer. And one of the arguments that was made was that developing the artificial intelligence is actually the easy part. It's far harder to get it implemented in clinical practice. And so I wanted to see if you could comment on that point and see if you found the same.
Oh, totally. Yeah, I mean, I think that the potential of AI is widely recognized enough that there are lots of tools that exist to, as you said, build the model very easily. Like, we sort of, I think, are now, in academia at least, live in an age where it's not actually terribly hard to plug and play machine learning models. There's like sklearn and all these other packages and stuff. You just take data, you take some package, some off-the-shelf package, and you build an amazingly accurate model. But as you said, that is only one very tiny portion of actually making a prediction model useful. And so I think that there are many, as I said, I think that as I learn more, I realize that it's not just about how to carefully implement it or convening key stakeholders and getting clinician end user sort of input when you implement it. Those are all small aspects of it, but the list of things I think you need to keep in mind is mind-bogglingly long. And in fact, I think some of them actually start with the design of the tool. So as an example, I think that one potential way to improve adoption of these types of tools is to perhaps design them a little differently from how we're designing them right now. I'm working on a project right now where we're evaluating, in surgery at least, the quality of prediction tools in comparison to validated, published best practices in terms of how AI should be designed. And the quality of most models to begin with is very poor. And so at the first step, the development is suboptimal, then how can you expect it to be translated to the bedside? And so one sort of potential area of improvement that I'm trying to learn more about and work on and conducting projects on is trying to see if there are ways to build the human's input into the model itself. So it kind of falls within the realm of this term that I'm sure you've heard before, human in the loop design. But the idea is, how can you effectively, so a lot of models right now are built with the goal of essentially outperforming the human. Like, how can we build a prediction tool that outperforms the clinician at some prediction task always? When in fact, I think that we need to think about these things a little bit differently and instead think about how we can bring the predictive capability of the human and the model together to create a decision-making or prediction paradigm that outperforms what either could do alone. And so one way to do that might be is sort of a project that I'm working on right now at BI is trying to essentially measure surgeon intuition directly and then try to create some mathematical representation of that intuition you can then build into models so that a model is not just making a prediction based on the patient and imaging and lab values and all these objective markers of their physiology, but also on the human's intuition, because the human is also capturing things about the patient that the model cannot see. And if you can bring those two things together, then hopefully you create a prediction tool that is not only accurate, but that surgeons actually want to use because they know that their intuition is incorporated into it. And then another aspect of how you design these types of tools is trying to figure out where they are actually useful. So if you built a tool that told you that a certain patient needed to be intubated when they were in severe hypoxic respiratory failure, that's not very useful. Like, your model is doing a very trivial task, telling a human something they already know. When someone is in hypoxic respiratory failure, you intubate them, obviously, right? And so how can you, and I think as a product of that, a lot of surgeons who are given model output, predictions, tend to not know how to or want to incorporate them into their decision making. There was this fascinating paper I read in a surgical journal that was published a year or two ago that They built a remarkably accurate model that predicted post-operative complications. And then they asked surgeons, independently, what do you think is the likelihood that this patient that you just operated on is going to experience post-operative complication? And they gave their likelihood. And then they showed the surgeon the model's output. And essentially no surgeon changed their mind based on the model's outputs. They had no idea or didn't want to, some combination of incorporate the model's input into their decision making. And so, yeah, I mean, a part of how you design these models is what types of clinical scenarios warrant these types of tools where the human has enough uncertainty that they want the guidance of a clinical prediction model. And so I think that those are all considerations in how you design them. In some clinical scenarios, you don't need it. And a model should know when it is actually clinically useful to deliver a prediction versus when it's not.
Yeah, I mean, I certainly think that the underlying model structure is obviously very, very important when we talk about clinical utility. But I think one other area that is important is where does the model live as far as the clinician's workflow goes? So do they have to go to an external tool in order to use it, or is it embedded within their workflow within the EHR? And so for me, some of the tools that have been easiest to implement from an AI standpoint are ones that were developed by the EHR, but then we run into some problems related to maybe the data set that they initially trained on is not the same as our patient's data set. And so is it generalizable versus if you developed one internally at your organization, that's going to generalize very well to your patient population since it was trained on their data. And then you have all these issues with third-party tools trying to bring them into your EHR. I mean, even with Fire, it's still not as plug and play as they make it out to be when they market it. So any thoughts on that big challenge is the way I see it, because a lot of these are not going to take off unless it's embedded in the workflow for the physician and getting it in there, especially when you can't even cite a large clinical benefit. I mean, you can improve detection rates and improve predictive performance, but if the outcomes don't change, why should I ask my IT department to put in this labor to implement it?
Yeah, you hit on a point that I am slowly starting to realize is so the idea of bringing a model to the bedside, of course, includes how you design it and those sorts of things, but the actual operationalization of bringing something to the bedside, as in creating an easily accessible dashboard that a clinician can open when they are seeing a patient, is actually, it seems like a trivial task, but it is unbelievably challenging. I think over the past couple of years since starting the fellowship, I've learned truly how much iceberg there is underneath the surface that you just don't realize. I mean, it's a monumental task, and I think that the technical challenges for every health system are probably a little bit different because of where the data is that you need and all that stuff. But yeah, I mean, I would say that a lot of utility of these tools comes from being able to deliver real-time predictions. And in silico, when you're designing the model, you presume that this model will be used in real time. But if you want to actually then put it in a large health system and have clinicians use it, giving it the data it needs in order to generate real-time predictions is extremely hard. And I think that in order to tackle that problem, first thing you need to do, as with a lot of problems, is sort of convene key stakeholders. And I think the key stakeholders in this case, in terms of translating a prediction model from something that you designed in silico to delivering real-time predictions at the bedside, step one would be convening the key stakeholders in that, and those key stakeholders are clinician end users, of course, the software engineer who is sort of taking the data scientist's model and building the dashboard for it. And you also need some sort of hospital IT administrator on your team as well, who can tell you, here's the data repository where the data that you're looking for sits. And here are like literally the tables where you can find the elements that your prediction model needs in order to generate a prediction. And here's how we can get these data elements to your model in real time when the physician is opening the dashboard. Yeah, and so understanding that data flow is critical. And if there isn't pre-existing documentation on where all that data sits, then you need a hospital IT administrator who will be able to guide you.
So you've worked a lot, I guess, on internal development of artificial intelligence. one of the issues that we have on the operational side is, okay, so we have a great NLM resident that developed this awesome artificial intelligence program, wants to get it put into place and operationalized. What happens when you graduate and leave? Who's maintaining that?
Yeah.
That we had at previous place I worked, that was an issue. I mean, before we had a commercial EMR, we had a kind of a custom homegrown one, and we did have a lot of custom code, and some physicians would develop it and leave, and maintaining it became a challenge. How would you deal with that maintenance issue?
That's an excellent point. Yeah, I mean, I think it comes down to so it's a personnel issue and then also a model design and model updating. Like a lot of models that you'll end up building will become you spend all this time deploying it, and then by the time it's deployed, you realize it's obsolete because of some data set shift that has occurred that has totally, some new ICD code that was introduced that totally renders your model useless because of some data set shift that your model does not account for. From a personnel standpoint, I think that part of the deployment process should be finding a long-term operational home for the model. So if you're building a tool that, I don't know, that predicts something in the operating room or whatever, then Department of Perioperative Services should want to own the tool in the long run, whether that means allocating business analysts or informatics people in the health system to updating it periodically. But almost as importantly, I think, is you should be able to design automated systems, or at least have a plan for how you are going to account for the inevitable data set shift that occurs very soon after you deploy this model, so that it's not irrelevant. I mean, your paper from a couple of years ago might have shown that the AUC was great, but then by the time you actually get it to the bedside, however long later, its predictive performance has likely deteriorated some untold amount just because of, again, how changing physician practice patterns or changing coding patterns or what have you. And so I'll give you an example of how we've done that at BI. So we deployed a prediction model that essentially predicts how many opioids a patient will consume after surgery to give surgical prescribers a good idea of how much to responsibly prescribe when the patient goes home, so that you're not like prescribing 30 pills when they only need one, kind of thing. So essentially to sort of tackle post-surgical opioid prescribing. Opioid prescribing and also opioid consumption and patient opioid needs is a moving target, and it changes. It's very fickle. It changes with public opinion around opioids, and it changes with new initiatives at a federal level. There's so many forces that influence how many pills a patient will consume when they go home. And so a model that you designed or you initially trained in 2018 is likely to be irrelevant now because of all the new sort of stuff that has happened in the around opioids in the news over the past several years.
Yeah, to go along with that, I heard somebody recently say that almost all the data pre-COVID is not irrelevant, but I mean, it's likely to be really skewed with today's patients population.
That's totally true. Yeah, and in fact, COVID has undoubtedly influenced opioid prescribing and opioid consumption as well. Like there's no question about it. And so how do you adjust for those sorts of things over time? And so what we essentially built as part of our recognizing that this would be an issue and that we don't want our model to become obsolete. We also concurrently designed a sort of continuous opioid consumption collection tool. So essentially patients at BI every day, patients who are discharged after surgery from BI every day are sent an automatic text that asks them to quantify their opioid consumption at home. And then they just sort of report how many pills they've consumed, and that's the data point we need. And so essentially every day there's a database that's being updated with the latest consumption data from patients at BI. And so we can periodically recalculate new consumption metrics for various procedures and see how it's changing over time, not only for evaluation purposes, but now we have a perpetually updated training data set. And so annually or with whatever frequency, we can retrain the model, update parameters based on what consumption and prescribing patterns look like right now, as opposed to what they looked like when we first trained the model in 2018 with our initial data set. And so I'm not saying that every model you deploy has to have some automatic system but you should also be mindful of and want to look at essentially, you should want to have some sort of system whereby you query whatever for the latest, you get the latest data, and you use it to understand how your outcome of interest is changing and your predictors of interest are changing. And then if they've changed a lot, then you need to have a plan for how you're going to update them all.
Yeah, I think that's a really good point. And certainly for my organization, it'd be very hard to maintain that internally. So we would certainly need to lean on a third party, I think, to help us with that. Yeah. One other big hot topic with artificial intelligence right now is the potential for introducing bias and amplifying bias. Based on the training data set, if there was bias in the training data set and you take that algorithm, it was trained on that biased data set, it's going to introduce bias in your population. So how do you all think about that issue and in ways to mitigate amplifying bias?
Yeah, that's the $1 million.
It's not an easy question.
Yeah. I guess I'd say a couple of things. That is a huge problem, and I don't think anyone really has identified a clear solution. The way we sort of approach these sorts of things is yes. So there are, in retrospective observational data, there is inevitably going to be biases that you're aware of and lots that you were just totally unaware of. And the 100% certain way to eliminate bias from retrospective data is to have it generated by health systems that don't have inherent bias within them, that is not a practical solution, at least in the short term. So given these biases that you're aware of and unaware of, how do you mitigate them? Well, there are statistical ways to either. You should always be sort of looking out for opportunities to leverage natural experiments to mitigate potential bias, statistical techniques to reduce bias. But I would say that bias or not, I think that there is tremendous value in using prediction tools trained on this type of data in the first place. And I think the reason why is because to be quite honest, I think we underestimate the sometimes maybe I would say irrationality of how lots of clinical decisions are made. And humans fundamentally make decisions not always based on of the scenario at hand. And so, yes, obviously lots of humans practice with sort of inherent biases, but they apply those biases in often very random ways. There's this great book that was just published in May of last year called Noise, A Flaw in Human Judgment by Daniel Kahneman. It's an amazing book, and it's just about how we humans sort of, in medicine, outside of medicine, when we make decisions, we're very noisy in how we make them. And yes, we do have biases that infiltrate into our decisions, but the predominant force in how we make decisions at the bedside or otherwise is very noisy. And so one of the solutions he actually proposes, and I think that this is the sort of mentality that we've adopted as well, is that AI is an excellent noise reduction technique. And so what AI does that humans cannot do is consider, sort of very objectively learn relationships from data and then apply those same exact relationships to every scenario. And humans do not make decisions in very standardized ways. And so a good start is to at least standardize care and standardize how clinical decisions are made. And once you can standardize those things, then standardized care is better care. And so I think that, yeah, the AI deploying AI at the bedside does not solve the bias issue, but it mitigates the noise issue at the very least.
Having a general awareness is going to help. And then at the same time, when you're periodically reviewing your tool to make sure it's still accurate with new data, you should probably also make sure that it's avoiding bias as much as it can. So I know we only got a couple of minutes left. Are there any projects or anything that you want to highlight or any future work that you're looking for?
Yeah, so several, but I think that the one I mentioned at the very beginning is something that I'm particularly interested in, which is trying to understand how the physician's behaviors and the physician's intuition can be represented in machine learning. And I think that that's sort of a sort of proof of concept that I'm working on to try to show that models can be built in a way that leverages the best of both computer learning and human learning. And often I think that we tend to view these things as very adversarial. It's like we want to deploy this model with the intention of replacing the human or automating this task so that the human no longer has to do it, when it's in fact no. I mean, the idea is that we should be building models that leverage the best of both. And so, yeah, I mean, I think that's sort of the area where that's the area of model development that I'm most excited about right now.
That sounds very exciting. Well, Jayson, thank you so much for coming on the podcast, and thank you everybody for listening.
Thank you, Jake.
I love this show. I love hearing from people on the front lines. I love hearing from these leaders. And we want to thank our hosts who continue to support the community by developing this great content. We also want to thank our show sponsors, Olive, Rubrik, Trellix, Hillrom, Medigate, and F5 in partnership with Sirius Healthcare for investing in our mission to develop the next generation of health leaders. If you want to support the show, let someone know about our shows. They all start with This Week Health, and you can find them wherever you listen to podcasts. Keynote, Townhall, Newsroom, and Academy. Check them out today, and thanks for listening. That's all for now.